Yeah. And today I'm going to talk to you about zero-knowledge encryption and ZeroKit and CareKit and our collaboration with Apple. And thank you all for joining. So just a few words about what we do with Apple. So as you may have read in the news, Apple launched CareKit about a year ago. And Apple's CareKit is really a big step for app developers in healthcare who want to be compliant and who want to break those barriers through that stop people spreading in healthcare. It's really easy to build an app, relatively easy to build an app today, but really to break through the barriers of compliance and have all those reusable parts that are already available through other healthcare projects, that's what CareKit did, the CareKit team did. And as you know, CareKit comes with lots of thoughts around security on the device. They encrypt data on the file system of your iOS phone, and they do. Apple is basically thinking everything with security at its core. If you can read the news about the iPhone and the FBI hacking, that's a good example and good demonstration of iPhone security. And we also realize that there are folks who are not from the iOS ecosystem, and maybe you're not using CareKit. You can use ZeroKit with CareKit, but you can use ZeroKit without CareKit as well. So what ZeroKit does is it extends CareKit security beyond one device to multi-devices or into the cloud, and you keep your patient data encrypted at all times. So that's what we're going to talk about, and we'll go into the details of how the technology works, and we'll show you how the sample applications work. All right, let me see if how do I get questions from you guys. Maybe I just want to put this to another desktop, and then I can walk back and forth to see the chat. Awesome. Cool. Now I think this works better now. Okay. So in summary, there's lots of data breaches that happen today. There's no week passing by without hearing of a major data breach. And here these bubbles are really just the top of the bubbles. This is a chronological order of the past 10 years. Of data breaches, and so when we studied those data breaches, we learned that it doesn't matter whether the breach has been caused by one tiny mistake or a gigantic architectural mistake. The point is that data gets out into the wrong hands, and that's what we don't want to happen. So this is typically a site where data ends up once your account is hacked. So haveibeenpwned.com. If you guys are shy to type in your email address, I typed in my old Microsoft email address from a while ago, and this is my Gmail. I've been hacked or breached 4 times with my Microsoft email, and my Gmail is still, well, a few weeks ago was still untouched. But the point is, once your account gets hacked, your data gets out to the dark web, and people will start to use your account and password to try to get your data. And this is what sells in the dark web. And what's happening in the meantime, there's lots of great innovations in healthcare, and CareKit is a good example for that. But there's AI Cure, for example, another startup, and a bunch of other startups are building really innovative solutions in healthcare. And the more adoption they get, the more patient they start to use their application, the bigger the risks, the more they fear that data will breach out. A couple of days ago, I've spoken to somebody who said, well, we have already built this awesome application in healthcare, but we are afraid to be the first ones because we don't want to suffer a data breach. We want to be a second or third one to make sure that if somebody gets hacked, it's not us. We are not the first hype. And this is not how it's supposed to work. So we decided that we give you guys, developers, an SDK that you can use to zero-knowledge encrypt data. So even if you get hacked, the hackers will not be able to interpret the data. And so what is zero-knowledge encryption? What is the encryption that we're talking about here? The zero-knowledge encryption is when you handle and store your patient's data, but you cannot access it on your servers. So literally you blindly handle that data on a server, and it's only the end users who have the appropriate keys to decrypt the data will see the data on their devices or in their browsers. So we are Tresorit. We are a company been around for 4 years. We already handle data for lots of users and customers in our Dropbox competitor product. And we realized that we make a greater impact if we release that end-to-end encryption in a form of an SDK to you guys. So a couple of years ago, we wanted to look at how hackable we are and sort of find proof that our architecture is indeed secure. And we offered $50,000 for anybody who can hack us. And the challenge was open for over 400 days, and we had over 1,000 hackers from really talented, skilled hackers from MIT, Stanford, lots of white hat hackers applied, and none of them could hack us. We even gave out the admin passwords for the tenants that we put out for hacking so that they can simulate an insider attack with a curious administrator who want to see their users' data, and it didn't work out because data is end-to-end encrypted and the administrators don't have the keys. End-to-end encryption has been around for at least a year in popular applications, in popular chat apps, but what we are doing today is we are taking this technology into healthcare and giving it to you guys so you can use it with patient data and in the market where it's most needed. And at one point, I'll pause for questions if you guys want to. And before I go in here, I forgot to introduce my colleagues on the line. So I also have two folks, Lotzi and Angeli, on the call. Lotzi is our iOS developer who will later speak to you about and show you some code for the iOS app. And Angeli is our Android developer. So we'll have them speak later. So what's the problem with the security today? What is the problem with the standard channel and at-rest encryption? This is one example. When Alice wants to upload that image of a flower into her cloud account. So what she does is, let's say she's using an iPhone or she maybe uses a browser. So what happens, she clicks the button to upload that file or submit to the server. HTTPS starts to kick in, and it will encrypt it. The HTTPS protocol will encrypt that form, which will travel up to the server. And when it arrives, your web packet to the server, even though it's HTTPS, it will decrypt because the web server, the HTTPS traffic terminates on the web server so that your web application code can access the data. And then hopefully a moment later, your at-rest encryption code kicks in and it will encrypt that data to go into storage. And that's what we call at-rest encryption. But the problem with this setup is that moment on the server, that one moment on the server of your data sitting there decrypted is very expensive and very long. So data typically shows up in log files on the server logs, data shows up in memory, and this guy may be already sitting on your server using a zero-day exploit or a known vulnerability, like the Heartbleed was about a year ago. And he's just sucking the data and the keys out of your server memory or your log files. This is one of the typical examples of how data gets breached out. And this is the standard encryption that most companies use. Pretty much every company uses this as a standard because this is how the internet has been built. So what do we do? What is client-side encryption? So it starts the same way when Alice decides to upload that beautiful flower image, but before that HTTPS encryption happens on the device or in the browser, one moment before that, we encrypt the flower, and then it will be the encrypted flower, which will be encrypted by HTTPS. And it arrives on the web server, gets decrypted, but it's still the encrypted image is in the packet, and it makes its way to storage, which means that the client side or client device encrypted image will remain encrypted throughout the network to this web server and into storage. It will never be decrypted. So wherever you look at and you find the data, whether you break into storage, whether somebody is sitting on a server, that person or bot will always see the encrypted data because it's been encrypted at the first place by the end user. So the challenge with this client-side encryption is, how does Bob get access to the data? So if somebody else wants to access with the data, how does he access it? And so if the encryption keys are exchanged or somehow managed between those users so that Bob can decrypt the data without exposing the encryption keys or the clear data to any server, that's what we call zero-knowledge encryption. If you guys have any questions, feel free to ask. Maybe I'll stop here for a moment and I'll open up for questions if you guys want any clarity. Let me just shuffle this in here. Feel free to type in question. Okay, so I got it. But that would include encrypted passwords as well. Is it a per client encryption? So Nicholas, answering your first question, but that would include encrypted passwords as well, right? Yes, but we have a even better way for encrypting passwords, and I'll come to that in a couple of minutes. Authentication is a really, really important part. Authentication is more than just encrypting passwords. I'll show you in a minute. Actually, that's the next presentation. So per client encryption, yes, you can use our SDK per device, or you can use one account across a user's devices. That's up to you. Thank you, Josh. What is my personal background? I'm a professional pitcher after pitching this for over 200 times. Thank you. Do you guys have any more questions for this? Okay, I'll move on and I'll peek back later. So this is client-side encryption, and getting that data, sharing that data that has been already encrypted and coming back to this user is the challenge with client-side encryption, and that's what we do with the smart key management without exposing Alice's key and without exposing the data, the encrypted data, in an unencrypted form anywhere. And I'll come to that in a second. But there's one thing that you realize, that you can have the best encryption of the world. If you have a sluggish user authentication, it's not worth a thing. So in other words, you can have really strong client-side zero-knowledge end-to-end encryption, but if Alice's password is stored somewhere in a hashed format, then this whole thing is not worth nothing. It's like having $1 million door, but keeping your key to that door under the mat in front of the door. Or under the pot, even better. That's something that everybody knows, under the pot. So we focus on authentication first to make sure that when you guys use our SDK, we give you an authentication service that is not gonna behave like the key under the pot for $1 million door. And once you already use our authentication, which I'll explain in a few moments of how it works, which is safer than most authentication services today, then you can seamlessly end-to-end encrypt data. Okay. So the other challenge with client-side encryption is that it has to work on every platform. Do your users care whether they are on Android tablet, Android phone, or in a browser or on an iPhone? Probably not. So it has to seamlessly work on every browser, and that's another challenge. We have to do lots of testing in Trezorit to make sure that the encryption works in every browser, every version, every platform. So let me peek back in here. One more question. What about accountability and traceability? For example, some law enforcement agencies wants information about weird activities, money laundering. So Nicholas, you can do that by creating an audit account, a special user account that has access to everything, and then you call that as an audit. Or you can also log things of what happened without logging the data itself. So it is up to you. We support you having an auditor account, but that is just another backdoor to the system. So if you want true zero knowledge, then you have to make that decision for yourself. Happy to chat about it more. I can share examples of some of our customers used audit accounts. Some of our customers make traceability and auditability without looking into the data. Okay. So what is so here? Maybe you guys wanna watch this close. I'm not cheating. I'm gonna walk you through our key management, because this is really important for you to understand. And I'll explain it twice, so I'm happy to go back. But this is really important. This is what sets us aside from other end-to-end encryption companies. This is why we are more flexible. For example, I've spoken to somebody yesterday about doing chat, encrypted chat. We enable multi-party chats, so we enable a third or fourth person to access the encrypted chat sessions after the fact. But that is all thanks to our flexible key management. So bear with me. Let me walk you through this, and at the middle, I'll ask how it went through. So this is how it starts. Alice is a nurse in a hospital, and she decided that she wants to encrypt this patient X-ray. So she took an X-ray of John, and she wants to encrypt it. So she'll create this key, which is a symmetric key. Just a simple symmetric key, and she'll use that blue key. I'll call it the blue key from now, data encryption blue key. She will encrypt that X-ray with that key. So far, so good. So now she will store that encrypted data somewhere in her database, in her app, anywhere she wants. Let's say she stores it in the patient records management system in the hospital. So the next thing that you want to do is she will want to put that encryption key into a safe place, right? So what she will do, she will create this logbox in the cloud. And this is something that we'll host for her. This is something that we'll create for her and host for her. But before she puts her data encryption key, the blue key that opens the X-ray, before she puts that up into this logbox in the cloud, she will take her own public key. In this system, every user has a public and private key pair. Just a recap, public keys can encrypt data and private keys can decrypt data. So she will use her own public key to encrypt that blue key. Now it's encrypted, which means that it's only Alice who can open that with her private key. Now that encrypted blue key goes into this logbox, and that's it. So the next thing that happens is Bob, the doctor, comes over and says, "Hey, Alice, can you please share John's data with me?" And Alice says, John, the patient. Alice says, "Of course." So she will re-download that encrypted blue key that she uploaded a moment ago. She will use her own private key to decrypt the blue key. And then she will download Bob's public key, which is publicly available. And she will do the same operation again that she did for herself, encrypt that same blue key with John's public key, which means that this version of the blue key can be only opened by Bob's private key. And then she puts that into the logbox. So in this moment in time, both Alice and Bob have access to the blue key. I hope it makes sense. So what happens next is Bob downloads the encrypted patient data from the cloud, and he also downloads his blue key, encrypted blue key, and he'll use his private key that he holds onto safely. He will open the blue key, which in fact will open the X-ray. So let me open for questions now. Does this SDK make HIPAA compliance essentially obsolete? Josiah, very good question. A very good question. The answer is technically yes. Legally, we are not there yet. We did a pilot with a CDN company to put sensitive data out on CDNs publicly with this encryption, and it's the same story as if they're encrypted at rest. So the question that Josiah asked is, does this SDK make a HIPAA compliant server essentially obsolete? The answer is yes. If you encrypt the data on the client device so that the data is encrypted from the first moment of its creation, then it doesn't matter where you store that data. But this will not win at court, for sure, not yet. Legal law is not there yet, and lawyers and data security experts sometimes disagree on things. So technically, yes, legally you would lose that case. So you would have to use our stuff and at the same time watch out for storage. But Josiah, just to finish my long-winded answer, what's important is, even though something is HIPAA compliant, the storage, without the proper encryption on the client side, it is up for hacking. It can be hacked. But if you client side encrypt something, it's much more difficult to client side. Like, you need that wrench again for the users. So Juice, yes, thank you for the great question. Okay, so when will this be legally HIPAA compliant? When will this be legally HIPAA compliant? Legally, so in the future we would not need HIPAA compliance. Yes, actually we are already HIPAA compliant, and with this solution, with our SDK, you can be HIPAA compliant faster and easier, because you don't have to worry about the data security. All you have to worry about for HIPAA is the training and the compliancy of your staff and company. There are parts of HIPAA that are not technical, security related, so you have to do that, and we'll do the data security. So thank you for the questions. So I hope that this makes sense so far, that how data is encrypted and decrypted. Any more questions for what I've seen? Anybody who wants me to go back and repeat this last 2 minutes to make sure that it goes through, please just type a yes. Okay. So let me quickly walk you through again. and at this time this will be faster, but it's really important that this goes across. So I'll start again. So Alice is a nurse in a hospital, and she takes this X-ray of a patient. And she will want to encrypt that X-ray. So Alice will create this data, this blue key that she will use to encrypt that X-ray. Now she encrypted that X-ray, and she puts that encrypted X-ray into storage, into her own database, or into her app's database. And now she wants to put that blue key into a safe place. So she will create this logbox, which you call a Trezor, in the cloud, and before she puts that blue key in there, she will use her own public key to encrypt the blue key and puts it there. And now Bob comes over and says, hey Alice, can you share John's X-ray with me, or John's data with me? Alice says, of course. So she will re-download that blue key from the cloud. Her private key opens the previously encrypted package. That's her version of the blue key. And she will download Bob's public key and encrypt the blue key with it. And now we have the same blue key, one for Alice and one for Bob. And now Bob downloads the encrypted X-ray and downloads his encrypted blue key. He's using his private key to open the blue key, which in fact will open the X-ray. So that's how it works. And let me pick here. Thank you. But then you would say, okay, Dave, this is all fun and it looks secure, but how about the private keys, right? Because we saw that the private key opens the blue key. So do you want me to store the private key securely? Because if you do, it's not worth a thing. So let me show you how you get the private key, because you guys don't have to do any of this that you see here. We do this for you. And this is how we store your user's private key. And it's really important to understand. So when Bob, and this is the authentication question that you asked earlier. I think Nicholas did. So this is how Bob gets his private key. Remember, the private key opens the blue key. So, and then the blue key opens the content. So this is how Bob gets his private key. When Bob logs into the system, he types in his password or puts in his Touch ID. From that password or that secret, we create an iterated salted hash on the client device or in the browser, and we derive a key from it. And then we create another iterated salted hash with another algorithm, and we derive another key from it. So long story short, we have two keys that we derived at login time, real time, from Bob's password, and then we throw away Bob's password from the memory. So we have these two keys that we derived from his password, and then the next step is we want to check whether Bob's password is correct or not. The way we do it, and this is how we avoid storing password hashes, and this is the biggest value that you guys will see using our SDK, that you don't have to worry about authenticating users and storing those password hashes. This is what we do to verify Bob's password. So we run this SRP check. And SRP stands for Secure Remote Password. It's a Stanford-built protocol. About 25 years ago, Stanford built it. The SRP gives you, a long story short, SRP gives you a way not to store password hashes, but instead store something like a large number that you derive from Bob's password. And the beauty of that SRP is when you authenticate the user, instead of generating the hash of that password login time and comparing it with the hash on the server, we don't do that. You have one large number that we store in our user database, and this is another number that we generate. And the SRP tells us whether this number that we have on the server about Bob's password and this other number have been derived from the same password. This is what SRP tells you, which means that you don't have to store something in here. You don't have to capture and generate a hash on the client side that you can log in with on behalf of Bob, and that's a typical hash hacking, pass the hash attack. But we have something in here about Bob's password, and we generate something else in here, and the SRP protocol tells us whether those two things have been created from the same password or not. And this is why it's much more secure than hash-based protocols. Very, very few companies use SRP today because it's really hard to implement, but we did it for you, and it's really simple to use. So when this SRP check happened, and we confirmed that Bob's password is correct, so this derived key, this is working with the other key that we have on the server, then we got this little encrypted package to Bob, which is his private key, which can be only opened with this red key that we again derived from his password. And that's the private key that will open up the blue keys. And the reason why we have two keys derived here from Bob's password is if any point in the future we'll find a bug in the SRP system which may leak out this key, we don't want this key to open the private key. So we want this key that has never left the client device to open the private key. So this is how it's much more secure. Now, guys, any questions? And I totally appreciate if I lost you at this point. Just just type in "you lost me," and I'm happy to maybe go back a few steps and explain it again. And also, if you understood it, I'm curious to hear your reaction. How do you like it? Thank you, Josiah. All right. So it sounds like thank you, guys. Anybody at this point, don't be shy. Just type in "please repeat," because I want to make sure that you guys get it, how secure this is. So I'm very happy to repeat it one more time. So if I see one "please repeat" in the chat, I'll spend another 2 minutes just repeating it. Well, the last step about the second key. So the last step about the second key was that it would be much simpler if we derived just one key from Bob's password, but we derived two keys. This key on the left we use for the SRP check that is going through the network, and this second key we create because the encrypted private key that comes to Bob's client device or Bob's browser after a successful authentication, this is opening it. And if anybody captures this key on the network, he can access Bob's encrypted private key. So this is why we designed the system that it can only be opened with this key here that has never left the client device. Thank you. Okay, so let me move on a couple more steps. So now you appreciate how complex, and this is the simplified version of our key management, because in reality we have layers of blue keys to make sure that we can revoke permissions and we can flip the keys from time to time, because flipping keys is important to keep data safe and hack prone. So you appreciate this whole complexity, and this is the code. This is how it works, and this is how simple it is. So this is a Swift code which you guys probably all can read because you are coming from the iOS background. So this is one line of code to log in Bob. This is the user ID, and this is Bob's password field. Bob's password, you don't even have to capture Bob's password. We have this password control that will capture his password for you. And you will never see the password itself, so you don't have to touch the password. You can tell to your customers, you know what? I don't even see the passwords. I cannot even breach out the password. And to trust us, what we do with the password, that's one of the reasons why we open sourced our stuff, so you can see what we do, which is literally just to derive those two keys from the password. So this is how you log in a user. That's it. This is how you create a Trezor. Remember we had that Trezor with the blue key? In this system, every user has a Trezor. Every patient has a Trezor, sorry. So that you can encrypt data per patient, and then once a new doctor comes into the workflow, when a new doctor comes to work with John, you can just simply give that blue key to that new doctor, and the doctor is suddenly able to decrypt everything that's been encrypted previously for that doctor. So this is how you create a Trezor for a new patient or a lockbox. This is how you encrypt. So you just pass in the plain text that you want to encrypt, and the Trezor's ID, which is the patient ID in this example, and there you go. You got the ciphertext, encrypted text as a result. And this is how you share. You share this Trezor with this doctor, and that's it. And decrypt happens even simpler. It's just one parameter. You pass on the encrypted text, and we already figure out which patient or Trezor it belongs to. Can you touch on the performance of those transactions given the size of being encrypted, decrypted? Yes. So Christopher, thank you for the question. We did measure the performance of encrypting and decrypting and sharing. For encrypting simple data, it takes around 1 millisecond or less. It typically is less than 1 millisecond to encrypt a couple of lines of text. To encrypt larger, to encrypt not just database fields, but a file, let's say a 10 meg photo, is still under 1 second, which is a large photo. Oh, I'm sorry. The good one, text. So the question is, what is the performance of encryption and all those transactions? So normally for text fields in a database you encrypt, it is less than a millisecond, and we also tested with larger files like a 10 meg photo, and it's still less than a second. Okay. So let me move on. So in summary, so ZeroKit gives you two capabilities, two important capabilities. One is you can use our user authentication, and you will not be prone to pass the hash attacks, which are the typical attacks that have been used by many examples for data breaches, for just capturing the hash. Just using the stored hash of a user password and logging in with it. And we are also much safer against dictionary and brute force attacks because we don't use hashes, we use SRP. And so once you already authenticated your users with us, then you can end-to-end encrypt their data seamlessly as you saw it. So that's what we call zero-knowledge encryption and client-side or end-to-end encryption. So let's see an app in action, and for this I'm gonna use my iPhone. Here is my iPhone, and this is the sample CareKit app that we announced a couple of days ago or yesterday. So I'll start up the CareKit sample. So this is Apple's CareKit sample application, which we'll use to demonstrate some of the basic capabilities of how you can embed, encrypt, decrypt, and share and user authentication into your application. So we are using the basic ZeroKit login, which works with Touch ID. I'm logging in as a patient now. I already registered this user. So when you guys get your developer account with ZeroKit, you can start creating and registering and logging in users. So you already get an authentication service. So this is the basic CareKit app. If you guys know it, it's a simple app that allows a patient to track her progress over time, her recovery progress over time. So for this patient, I need to do an outdoor walk for 15 minutes and then a stretch and then take 2 medicines a day or 2 pills a day. So what we did with this CareKit app, the sample CareKit app, is we added this feature called My Doctors, where you can add a doctor and then share your care card and symptoms with the doctor. So if I go back, okay, I did my stretch, I took my morning pill, but didn't take the afternoon pill yet. So that's how I am. For my symptoms, yeah, I have a little pain, but my mood is awesome because I have you guys on the line. And this data is shared with my doctor, which I can revoke anytime. So we extended the CareKit app with cloud storage using CloudKit, Apple's CloudKit, but you can use any other storage solutions that you want. And we also added this sharing capability where patients can share data with their doctors. So this is how I tracked my progress, and now I'm logging out and I'm logging in with the doctor. So I was Alice when I logged in, and now I'm Bob. So I'm logging in as Bob. Sorry. I'm logging in as Bob, and I can see Alice among my patients, and I can just tap here, and the data is downloading, and the data already came through. So the beauty of this is, so this is how the application works, and let me show you how it is stored in iCloud. Because this is a fairly simple application. I think this is my iCloud account. So if I go to the public data and default zone, I think this is where we store it. You can see all these records, and these are the records of all the checkboxes or things that I type in. This is what a hacker would see. Created by this user. We don't even track user names. We have these random usernames, and you guys know which user it is. We don't want to know which user is important and which user is less important. So this is what the attacker sees because it's been encrypted from the beginning. So with that, any questions before we? Yes, thank you, Nicholas. Yes, actually, yes. So never use a 3-letter password. Fair point. Nicholas said strong passwords. Thank you. So with that, guys, let me hand it over to Lutzi, who is gonna walk you through the iOS app, the CareKit sample. He will show you some code and he will give you some hints of how you can deploy it. Lutzi, are you ready?
Hey guys.
Hey.
Okay, so I'm gonna share my screen. Hopefully you can see me now.
Yes, it's coming up. I can see.
Okay, so this is the CareKit+ZeroKit sample app that we built. So to demonstrate how you can use ZeroKit with CareKit. I'm gonna show you a few things that really just how easy it is to use ZeroKit in your apps. So the first thing you want to do is to set up ZeroKit. You really need one thing. It's an API URL that you will get once you register for ZeroKit. So you just really configure ZeroKit with the URL, and there you have it. So the first thing you want to do as a user, you probably want to log in. And our sample app uses CloudKit. It's Apple's iCloud storage. So if you're an iOS developer, you are probably already familiar with it. And we used it for, so this is why we used it for this sample app. So we don't want to use something that you have to learn from scratch. So for the login, the first thing, we get the fetch the user from CloudKit. And once we fetch the user, we have the user's ZeroKit user ID, and we have the user's password that they typed in the app. So we do not fetch it from the server, of course. And this is how you log in. It's just one simple call. What you have to know about password handling here is that we provide our own custom ZeroKit password, so you don't have to handle the passwords yourself. We capture the password and you don't have to touch it. So you will not accidentally leak it or log it or send it to a server where it really has no place to be. Okay, once you logged in, you want to encrypt the patient's data. And this is also a simple call. You encrypt the plain data. It's in CareKit, it's usually the patient's activities or events that are already stored locally by CareKit. You have to specify a Trezor ID. It's the logbox you want to encrypt it with. So once you encrypt it, you will have a cipher data that's all encrypted, and if anyone wants to see it, they will have to have the keys decrypt. So how do you decrypt? We also have a function call for decryption. You pass in the cipher data. We will find out which Trezor it is encrypted with. If you have access to that Trezor, then you will be able to decrypt the data and you will get back your plain data. you will also want to share your data with others. For this, you will have to share your treasures, and your keys are managed by those treasures. So you will have to specify which treasure you want to share and the user ID. It's the ZeroKit user ID you want to share with. So this is one function called to share, and this operation has to be approved by your server. So if a client-side hack happens, you still have control over the operations. And this is what happens here. The sample app uses a mock server, so it's really built into the client app to make it as simple as possible for you to understand and to run. And this is what happens here, this approval. Where you get this sample app from, if you sign up for ZeroKit and manage.treasury.io, you will see sample apps. And you can get this CareKit sample app easily from here. You will download a script. Here's how you can run the script. This sample app will already be configured for you, and you can, but you will have to do a few additional setup on the Apple development portal to make it work, as it uses HealthKit and uses CloudKit. This is something you will have to configure for yourself, and we provide a step-by-step guide in our README on our GitHub repository. If you're not a CareKit user or you're not interested in healthcare, we have a really simple sample app that you can see how to use ZeroKit. So it's much more simple. You can really understand the basics of ZeroKit without the complexity of CareKit here. You can also download it from this portal. If you download it with the script, it will be already configured for you. And you can also find it on GitHub. It's where you can find the ZeroKit iOS SDK, and we also provide an example application for you. Okay, so do you have any questions? Okay, this is a good question. So in your examples, you are using iCloud. Is Apple opening this up now for healthcare data? Well,
I can take it, Lottie. No,
okay.
The answer is no. And this is the same question I think Nicholas asked earlier. So even though, as you could see on my screen, when I looked into the iCloud data, it was all encrypted text. Legally, iCloud is not HIPAA compliant, as far as I know. So Apple doesn't want you to use iCloud. However, technically, you are safe because you already client-side encrypted the data. So the general guidance that we give to our customers and you guys is use the storage service that you are using today. Make it HIPAA compliant or use a HIPAA compliant storage. But it's not the HIPAA compliancy that will give you security. It's us who give you security. HIPAA compliancy will give you compliancy and the checkbox for the two things to work well.
Okay.
Lottie, anything else you want to talk about?
No, I think I covered.
Cool. Thank you.
Sure.
So question, everyone, do you, who wants, and maybe you can approach me after the session, but who would be interested in a follow-up webcast or call of helping you guys go through and deploy CareKit in your own Apple developer account and iCloud account? Because if there's at least 3-4 people interested, yeah, definitely interested, then we can have a targeted session maybe next week to maybe an hour dedicated just for this to help you guys go through. Maybe we'll show you step by step, and then maybe it can be it can be more engaged when you don't just type, but we'll do a Skype call, or you guys will join as presenters, so you can show us your screen and sort of go through that that troubleshooting session. If bring the SDK pre-existing apps. Yeah, we can do something like that too. Okay, so we'll organize something. Let me also show you the web. Thank you, Lottie, for the great demo and source code. Let me show you. So second on the list that you guys were interested was the web app. So I'm not going to demonstrate the web app, but this is a brief overview. So this web app really consists of a few real simple HTML pages, and this is how you use ZeroKit on the web. So this is JavaScript running in the browser. So this is how you set up ZeroKit. This here does nothing else but taking the URL of your developer account, the tenant ID, and then in this line you simply ZeroKit login.login, you pass on the user ID, and we capture the user's password seamlessly to the user. So one line of code to log in. And then when it goes to encrypt, this is the JavaScript that encrypts. Again, we initialize the SDK with this line. This is the your tenant ID here that we parse in this beautiful way. This is a single line of code to say who is the logged in user. This is how you create a Trezor. If it's a new patient, let's say, and you want to create a new Trezor, this is how you create a Trezor, and you get this Trezor ID as a return parameter. This is how you encrypt. You say, I want to encrypt with this Trezor, with this Trezor's keys, this text I want to encrypt. And this is how you decrypt. You just pass on the encrypted text, and then it's decrypted. So you can see that there's no key management, there's no keys and certificates involved. You literally just call, there's one single lines of call for encrypt and decrypt and share, and this is how simple it is. Any questions to the web or in general? Okay, I got something in here. You probably already answered this, but I think you missed accountability and traceability. Some law enforcement agencies wants the information about weird activity and money laundering, suspicious JavaScript is always global, I'm guessing. So it would be the same as the Android stuff. We talked to the Pluto guys. Spring. So Nicholas, yes, very. I like. Thank you for the question. So the question is, how can you audit this? How can you end-to-end encrypted data? How can you audit this? And this is what the government's problem was with WhatsApp, for example. They cannot audit how people chat. So you have to make a decision as a developer how much data you want to log in the client device, how much data you want to encrypt and how much data you don't want to encrypt, how much data you want to audit or store for auditing purposes, and how much data not. So it's not all or nothing. You can decide if you want to encrypt only your patient's social number and last name, then be it. If you want to encrypt only your patient's birth, month, and day, and social security number, and the x-ray photos or the patient records that you take from him, then be it. You decide where you call encrypt and where you not call encrypt. I suggest that you think it through what data is the most important to be encrypted and what data can be left unencrypted, that is still searchable or auditable, and absolutely you can be selective of what you encrypt and not. So next one is, and this is the last topic for today. I'm going to hand it over to Angali for a quick walkthrough of our Android app. Angali, the stage is yours. And yeah.
Hi, everybody. I am also work for CareKit, and I will show you a quick example about the Android example app. Let's start with the share screen. Can you see your desktop?
Mm-hmm. Works well.
So here on the emulator, can you see the example app with the very basic functions and functionality? We have already registered 2 users before for demonstrate how it works. So let's log in with the first one with the strong password, of course. And here we can create a Trezor. It's a little bit. Yes, and after that, here we can see the generated Trezor ID, and we can encrypt some text, for example. Yes, here you can see the encrypted text. We can copy it to the clipboard, and we can text the decrypt. Yes, and we will share with this Trezor with the other user. Was user 02. Yes, and
this is when key management is happening in the background.
Yes.
So the app exchanges the keys. If you remember when Alice shared the blue key with Bob, that's what's happening here.
Yes, and then now I'm looking with the user 2 to see the encryption. And paste here the encrypted text, and yes, you can see the same text. So this is the very basic Android app about the using of the Android SDK. And let's see some line of code. How can you use it? First of all, you need this line to include the SDK into your application. It's only one line. With the Gradle Dependency Manager, you can use it. And for example, let's see, login. It's also as simple as you see it in the iOS application. So you have to call the login function with the user ID and the password, and you can handle the results in 2 callbacks. The first when the login was success, and the second one when it's failed. So you can also use here password export or a password edit text, which will provide you a safer way to handle passwords. So you don't need to handle byte arrays or strings with passwords. So it's a safer way to provide us the password. So yes, and here, for example, the decryption method, you can here see how simple it is. Only one parameter is the ciphertext, and in the result, you can see the decrypted text. So I think that's all. Have you any questions about?
Angali, there's one question. Can you see how long it takes to create a Trezor? Can you show it in a demo?
Okay, 1 month. Yeah, the first one was a little bit slower. I don't know why, but it should be a very quick action. Yes.
Maybe it's the app that makes it to look slow, but it's fairly simple to create a Trezor. I think we did performance testing. I can actually look it up. Actually, it's funny, but I have it here. So to create a Trezor, Trezor creation performance. And here is the average Trezor creation time. Yes, so on average it's 400 milliseconds to create a Trezor, and with all the keys necessary and store it in the cloud. It's 400 milliseconds. So you create the Trezor maybe when you register a new patient, or the first time that patient logs in, that patient will create the Trezor, and then she will keep sharing those the Trezor with doctors and other people as she wants access to be granted, and doctors can reshare the Trezor simply with another doctors. Anneli, anything else to show us today?
No, I think I finished.
Thank you. Thank you so much. Thank you all for coming. This is really the end of the show. So if you have any questions left, I actually have one question that I wanted to answer for Nicholas. If ZeroKit can be used with another identity provider. Yes, so we support OpenID Connect to propagate login with other providers. To other providers, but right now we don't work with logging into another authentication provider and propagating that to us. And the main reason is because all the authentication providers that we looked at, they are hash-based and really simple to crack and hack. So we decided that we wanted to use our own authentication service and make this whole system zero-knowledge encrypted. Because if you're using an authentication service like Active Directory, then somebody is already aware of your user's password. Somebody is already storing, like Microsoft is already storing that password. That hash is easily hacked. So we wanted to give the full security and position our ZeroKit primarily as an authentication service, which also does end-to-end encryption. So this is coming down the line, but right now, if you want to work with another authentication service, you have to have this secondary ZeroKit password, which we call maybe a second factor or an encryption PIN code. But really our main use case that we'll guide you guys to do is use ZeroKit for authentication. And this is something that I also, for closing, I wanted to show you our pricing, because this is something that, so we created our pricing also to enable developers to use us for authentication almost literally for free. So this is our pricing, user authentication. We give it for free for up to 1,000 monthly active users. And then we charge you 1 cent beyond that per user, per monthly active user. So that means that you can have 2,000 users, half of them are active monthly, and then you would still pay nothing for us. And once you start to end-to-end encrypt data for those users, so with this user authentication, you already get an SRP-based authentication that is much more secure than today's authentication services, which cost you more than 1 cent in general. So we are much more, much safer, much more secure, and we start free and really cheap with 1 cent a month. We want you guys to be able to grant privacy to your users this way with no cost. And then once you start to end-to-end encrypt for your users, we charge you $89 for every 100,000 operations. So every 100,000 encryptions, we'll charge you $89 per month. During the beta, the public beta for the next couple of months, we are free. So I would encourage you guys to log into your portal, managed.treasury.io, and download the sample apps that you saw today. If you want to start with something real simple, maybe download the browser viz, the web sample. It's as simple as it gets. Or the iOS sample app or the Android sample app. They're really as simple as you saw in the previous Android demo. If you are an existing CareKit developer and you want to use our sample code with of how it works with CareKit, go ahead and download the CareKit sample, and we'll invite you guys for next week for a call where we can help you get going. If you want to go deeper into integrating ZeroKit into your application, we'll do that and guide you through. We like to believe that it's really simple what we built, so you should be able to get going easily, but we are here to help you and answer your questions. Hopefully you also accepted our Slack invite to our Slack channel. Feel free to log in and ask us questions there. We would love to hear your feedback and love to learn more about you guys and work with you and deliver happiness and privacy to your users. So with that, I'm closing and thanking you for coming over today. If you have any more questions, feel free to paste it here or type it in here. If no, then we'll follow up with that next call where we go one level deeper for you guys. Oh, the flow diagram, that was one question. Do you have flow diagrams to show the system works? And other feedback. Thank you so much for the feedback. I'll show you a flow diagram. That is something that I've got in my slides. So this is a flow diagram. So this is where your app is running. And this is our SDK in your app. So it could be a browser app or it could be your mobile app. And this is the SDK, client-side SDK. And then here's your backend and here's your database. You keep passing data to your backend and storing in your database as you do normally, but you would just, before you pass it on, you would encrypt the data with the encrypt function. And then data comes back to your other users decrypted, and using the ZeroKit library, they will encrypt it. The REST APIs on the server, you call from your backend to validate users. So once a new user registered, you validate that new user, and that user can now log in. So you can do that validation by sending the user an email to say, hey, can you verify your email? Or some of our customers like to call in those users to their office, show your ID, show that you are a real nurse or a real patient, or let me give you a call and verify whether you can tell me a secret or something. And that's how we manage users. And also your server has the ultimate access to approve sharing operations without seeing the data that is being shared. And this is important because is this person, do you really want this person to be able to share the patient data with that person? Can a nurse share data with that person, with doctors, or not? And this is when you overrule the client applications allowance or client applications operation on your server to enforce a business logic without seeing the data. Nicholas, I hope it helped to answer your